What if you could take any shape you can imagine on a computer and hold it in your hands just hours later? That's exactly what 3D printing makes possible. We're going to walk through the entire process, from the first click in a design program to the moment a finished object emerges from the machine. Traditional manufacturing removes material. You carve, cut, or drill away from a solid block. 3D printing flips this completely by adding material precisely where it's needed and nowhere else. This additive approach produces almost zero waste, and it unlocks shapes that are physically impossible to mill or cast from a mold. Every 3D printed object follows the same journey through 3 stages. First, a 3D model is created or downloaded as a digital file. Then, specialized slicing software breaks it into movement instructions the printer can follow. Finally, the printer executes those instructions, building the object one thin cross-section at a time. Slicing software is the brain behind every print. It takes your 3D model and calculates exactly where the printhead needs to travel for every single layer. It also decides where to add temporary support structures for overhanging sections, how dense to make the internal fill pattern, and how many perimeter walls to trace for structural strength. The precision involved in 3D printing is extraordinary. A standard nozzle is just 0.4 millimeters wide, smaller than a pencil tip. Layer heights can go as thin as 50 microns, which is half the width of a human hair. A typical desktop print runs anywhere from 1 hour to over 20 hours, depending on size and detail level. There are 3 dominant 3D printing technologies, and each builds layers in a different way. FDM melts plastic filament and traces it out like a precision hot glue gun. SLA uses ultraviolet light to cure liquid resin into solid shapes. SLS uses a laser to fuse powdered nylon or metal. All 3 share the same fundamental strategy: build up from nothing, one cross-section at a time. FDM and SLA are the 2 most popular desktop technologies, and they each shine in different situations. FDM wins on cost, material variety, and durability. It's the go-to for functional parts and large prototypes. SLA dominates when surface finish and fine detail matter most, making it the choice for jewelry, dental models, and miniatures. The 3D printing industry has seen explosive growth, driven by falling hardware costs, better materials, and rapid adoption in aerospace, healthcare, and consumer products. The global market has more than doubled since 2019, and analysts expect continued growth as the technology becomes faster, more accessible, and capable of handling production-grade volumes. The genius of additive manufacturing isn't just the technology, it's the philosophy. By building one thin cross-section at a time, you can create any shape that exists in mathematics, regardless of complexity. This means the cost of complexity is nearly zero, and an intricate lattice costs the same to print as a simple box. 3D printing has already transformed prototyping, custom manufacturing, and healthcare. Surgeons print patient-specific implants. Aerospace engineers print rocket engine components. Artists create sculptures that couldn't exist any other way. The layer-by-layer revolution is still unfolding, and the next breakthrough is being built right now, 1 micron at a time.